are appearing in a question that you are appearing in an exam that has mostly objective questions, right? So since it is objective questions, there will be no draw this graph or identify this graph. No, those questions are quite easy. So there will be no questions of that sort. Whatever maxima minima problems you get, sometimes they will be solved well by using the wavy curve method. Okay, so the wavy curve method is, well, not exactly the graphical method, but then you should also know the rotation of quadratic graphs, translation of graphs, how graphs are impacted when you increase the variable, and so on. Okay, the first thing that you need to know is what a quadratic equation looks like on a graph. Now I think many of you know this. Can you tell me what is the shape of a quadratic equation on a graph?
Parabolic.
It is a parabola. Yes, well done. Can you prove it? Yes, it has to be proved, right? You cannot believe anything that people say. किसी ने parabola बोल दिया तो parabola, right? ऐसा थोड़ी होता है. There must be a proof of it. How will you prove it? So we will do this today. Quadratic graphs. Okay, so start with the basics. So what is the quadratic expression? The quadratic expression is ax square plus bx plus c is equal to y, right? With a not equals to 0. So y is equal to ax square plus bx plus c, where a is non-zero. Okay, so this is the quadratic expression. All of you agree with this, right? Now we have to show that this is a parabola. So to show this is a parabola, you can proceed very similar to what we have done when we derived the quadratic formula. Okay, Siddharacharya's rule, that derivation is very similar here. So we will first get a out, okay, because a is a problem. So if you take a outside the right hand side, so you'll get y is equal to a into x square plus b by a x plus c by a, right? And then you do the same forming the squares method. So y will be equal to a into, how did you do the squares method? Anyone remembers? You did this, right? We set y equals to 0 and we obtained the quadratic formula, x equal to minus b plus minus root over b square minus 4ac by 2a. We did this earlier. Can you repeat this here? How can you form the square? Yes, what will be the square term? Anyone? No, that's disappointing. So you can write this as x square plus 2 into x into b by 2a plus b by 2a whole square plus c by a minus b by 2a whole square, right? I can add and subtract b by 2a whole square to complete the squares. So a will be equal to root over of x plus b by 2a whole square. What will be the term after? Basically, I want you to simplify this term, this thing, and tell me what you get here. Take the LCM. This is simple algebra. Don't get stuck here. Yes. What will be that term? Remember, this is a positive term. This is also a positive term. The only negative here is just beside it. So I want you to write it in a negative term, not a positive term. Okay, I have not given plus here. So if I've given minus here, that means you should be doing something like b by 2a whole square minus c by a. Okay, so simplify this and tell me what you get.
minus b square minus 4ac divided by 4a square.
Minus b square minus 4ac by 4a square. What is b square minus 4ac? You have learned this earlier.
Discriminant.
Very good. So can I write it as minus d by 4a square? That works. Everyone, I hope you have understood this step. I'm not expanding it. So y is equal to x plus b by 2a whole square minus d by 4a square. That works, right? So now what will I do? I can just, well, multiply the a, right? If I multiply the a, the 4a square, one of the a's will cancel and one a will remain here. So I can bring that d by a to the left hand side and I'll get y plus d by 4a is equal to a into x plus b by 2a whole square. Yes, agree everyone? Just simplifying this step. So what does this become? Does not this become a parabola in y equal to ax square format, where y is equal to y plus d by 4a and x is equal to x plus b by 2a? A little bit of variable shift gives us our answers. So since we showed that y equal to ax square, then we can conclude, therefore y equal to ax square plus bx plus c, a non-zero, is a parabola. Okay, that is the proof. Now nowhere will they ask you the proof directly, but while doing this proof we revise certain methods, and there might be questions where you would need to do a few sections of the proof. Okay, the questions will not be like show that the quadratic graph is a parabola. No, you will not get those questions. You might get a different type of question where you will be using these techniques. Okay, so are you all convinced that y equal to ax square is, this is basically x square is equal to 4ay, that format, right? So that format, and this is a parabola. Now we have applied a shift to the variables, right? Capital Y is the new variable, which is y plus d by 4a, and capital X is x plus b by 2a. So that is after shifting. If we remove the shifting, what would have been the vertex of the parabola? Anyone? So if this is the parabola, right, and we get a, for a parabola of this format, the vertex is at the origin, right? So y, sorry, x comma y, capital X comma y, is equivalent to the origin, right? Because for this particular parabola, the vertex is at the origin, but this particular parabola is obtained by a shift using these variables. So this will imply that y, no, x plus b by 2a comma y plus d by 4a is equivalent to the origin, right? So what does this imply? This implies x comma y is equivalent to minus b by 2a comma minus d by 4a. So this is the vertex of any general quadratic parabola. Clear? Okay. So the shape of the curve y equal to ax square plus bx plus c is a parabola with its vertex at this point. Okay. So note this down. Well, just make sure you make a small note. I'll obviously send the entire notes. I think I forgot to send the notes last week. So I'll send last week's and this week notes together. Okay. So vertex. This is the vertex of the parabola. Fine. All right. Now what? So now we will have to look into the variations of this parabola, right? So this parabola will be either shaping up or down. Okay, so a few cases here. Now let us discuss these cases. So in the first case, this is basically the section known as sign of quadratic expression. So the first case will be the parabola intersects the x-axis in two real and distinct points. Okay, so how will it look like? So this will look like here. Let me give you the diagram directly. I'm just giving you the diagram so that you don't need to draw it yourself. ये रहा. Okay, so this is case 1. All right, this says that the parabola, the quadratic, intersects the x-axis at two different points. What are these points called?
Roots.
Yes, fine. So now you can clearly see that the quadratic expression y, it is less than 0 between alpha and beta, right? Beyond that, so fx is less than 0 between alpha and beta. Fx is 0 at alpha beta. Fx greater than 0 elsewhere. Agree? So this is the first one. Okay, now there will be a few more cases like this. You can imagine the next one. Let us write this as case 2. Again, I'll give you the diagram. So this, okay, now when will this happen? When will this happen? This will happen when you have normal quadratic equations, right? That means the discriminant should be greater than 0. By normal, I mean unequal roots. Of course, they are touching at two different points, so roots will be unequal. You can see them on this graph, which means the roots are real and unequal. If this was a complex graph, you would not have seen any intersections, right? So since you can see it on the graph and you can see two distinct points of intersection, therefore this is the case with d greater than 0. So if d is greater than 0, then this point, look at where this point is. So this point is on the fourth quadrant. So in the fourth quadrant, what is positive and what is negative? In the fourth quadrant, x is positive and y is negative, right? So this d and 4a, this section will be negative. If this is negative and d is greater than 0, that means a has to be greater than 0. See if you understand this logic. So d greater than 0, that is fixed. We also know a greater than 0. And for the other one, if we know that a is greater than 0, y has to be negative here. So therefore, b will also have to be what? B has to be positive, right? So b has to be less than 0. Otherwise, this will not work. Everyone clear with this? The point is in the fourth quadrant for this particular case. Now, if I shift it a little and everything goes into the third quadrant, then b can be greater than 0 as well. So we clearly see that for two intersections on the x-axis, d and a have to be positive. B not needed. Okay, because b could be either on the positive x side or on the negative x side, does not matter, it will still give you two intersections, but both d and a should be greater than 0. Okay, so from this list I will remove b. It takes both values, right? So no use trying to get any conditions fit with it, we'll just go with D and A, these two. They'll not move. Okay, fine. So these are the two conditions. All right. So what will be case 2 now? So case 2 will just be the reverse. Okay. So before I give you the diagram, can you tell me how it will look like and what will be the conditions? Okay. Before we move completely on to case 2, in case 1, what is the maxima of the graph?
Infinity.
What is the minimum of the graph?
Minus b by 2a.
No, the y-axis is the minima, right?
Oh, sorry.
Yeah. And the location is minus b by 2a, comma d by 4a. The independent variable always, the independent location always gives you the particular value. Okay. So the minima here is minus d by 4a. Of course, you don't need to remember this formula because when I teach you calculus, you will know how to calculate maxima and minima. But still, before that, you can use these techniques. Okay. So this is the next graph. In this particular case, what will you do? In this particular case, the quadratic equation intersects again at two different points. But what will be the difference between case 1 and case 2? In both these cases, you have what? In the first case, you had d greater than 0 and a greater than 0. In this case, are we going to have d less than 0, a less than 0? There has to be something different, right?
Yes, sir.
No, if d is less than 0, the roots become imaginary. Then you cannot see here. So d will
Sir,
still
you
be
mean
greater than 0, but
A
only
less than
a
0.
will be less than 0. Yes. So remember, just a will decide the face of the graph. Okay. By face, I mean if it is facing upwards or downwards. All right. So if I write 2x square plus 3x plus 5, you know that this is facing upwards. If I write minus 2x square plus 3x plus 5, you know that it is facing downwards. Okay. You don't need to check anything else. Just looking at the coefficient of the quadratic, right? The quadratic term, x square term. Looking at the quadratic coefficient, you can tell whether the graph is facing up or down. All right. That easy. So sometimes you need these before you begin a particular problem based on functions or something like that. All right. Those things will require graphs. Not always, but sometimes. Okay. Then again, the word requirement is a bit strong. Maybe you can do without it, but drawing the graph or imagining the graph will make certain problems easier. And that is the way you save time. Otherwise, you will get out of the exam complaining that paper was lengthy. Okay. That happens. All right. The quadratic intersect the x-axis at two different points. But here again, the mix will be different, right? By the mix, I mean certain positions will again be less than and greater than 0, but it will be different. So fx is greater than 0 in between alpha and beta. Fx is equal to 0 at alpha and beta. And fx less than 0 elsewhere. Okay. So again, what will be the minima of this graph? What will be the maxima of this graph?
Minima will be infinity and maxima will be d by minus d by 4a.
Very good. So here in the graph above, maxima would be infinity, minima would be minus d by 4a. Here minima would be minus infinity and maxima would be minus d by 4a. So in both of these cases, you see that the extrema is coming at minus d by 4a. Okay. So if someone asks you to calculate the extrema, the maxima or the minima for a quadratic expression, just calculate minus d by 4a. Okay. So you know where the location is. The location of that will be minus b by 2a. And the extreme value would be minus d by 4a. Okay. So here is a shortcut. Sometimes you would not be asked whether it is maxima or minima. Okay. And you might have to know it to move forward in the problem. So what can you do? You know that the extreme value will be minus d by 4a and the location is at minus b by 2a. So let's say minus b by 2a turns out to be something like minus 4 or minus 3. All right. So you calculate the value of the quadratic equation at 0. All right. So if you see that the value that you obtained is less than the extrema, that means it was a maxima, right? Because if you get a lesser value than at the particular point, then obviously it has to be a maxima, because maxima means that is the top value. If you don't, then it's a minima. Okay. Sometimes this one simple test will help you solve these problems much more faster. Rather than taking the derivative, putting f dash x equal to 0, taking the double derivative, setting it to 0, that is a lengthy process. Okay. If they ask you maxima or minima, then you know. But if they do not classify it and you just want to know whether the extreme point you obtain is a maxima or a minima, you can do that technique, or you can read it from the graph. Okay. Sometimes it is easy. So let's say you have a quadratic equation 2x square plus 3x plus 5. Okay. And you obtain the minus d by 4a to be 6, minus 6. So in that case, you know that it will be a minima. Why? Because 2x square plus 3x plus 5 is pointing upwards. And for a upward pointing parabola, you only get a finite minima. The maxima is always infinite. Similar logic can be applied to the second case as well. If you have a quadratic equation like minus 2x square plus 3x plus 5 and you get a extrema as 6, then you must know that it is the maxima, because in case 2 the graph will go infinitely downwards. So whatever extrema you get has to be the maxima, because minima is never ending, right? It will keep going downwards. So since I taught you the formula, do not always apply the formula everywhere. Use your intelligence. Okay. These exams are built on the concepts that I teach you, but they are built on applications of those concepts using your own intelligence. The person who eliminates options faster will answer faster. Okay. Sometimes there will be, not sometimes, but out of 10, there will be 4 problems that you will have to brute force. There is no way apart from solving it step by step. All right. But the other 6 questions, those are where the marks lie. Okay. The examiners will expect you to get those 6 right. And then among the 4, whoever solves the weird questions the most, they will be the top rankers. Okay. If someone gets 3 out of 4, that's 9 out of 10, right? 90%, that means top 4-digit rank. All right. So be very aware. This is the strategy for exams. Next, what happens when the parabola will be just touching the x-axis? So that in the previous 2 cases, we had the parabola intersecting the x-axis at 2 different points, right? So we know that that is the case corresponding to d greater than 0. But you could also have d equal to 0. In d equals to 0, we have equal roots, right? Or the roots of multiplicity 2. Same thing as equal roots. So let me get that image for you. You can tell me all of the conditions from the image. All right. So this will be case 3. Okay, we have not written these things here, right? So here you will have d greater than 0 and a less than 0. So what about here? What about d and a? What would you say? Which one is greater than 0? Which one is less than 0? Yes, in case 3. You can see the graph and answer. What will happen in case 3? What is greater than 0? What is less than 0?
A is greater than 0 and D is equal to 0.
Yes, correct. So A is greater than 0. How do you know A is greater than 0? Because the parabola is pointing upwards. Okay. Whenever the parabola points upwards, A is greater than 0. And vice versa. If A is greater than 0, the parabola must point upwards. Alright. So these two are related to each other. So that means D equal to 0 and A greater than 0. Okay. So what can you conclude here? Here, the quadratic intersects the x-axis once. Equal roots. So in this case, what will I have? I will have fx greater than fx equal to 0 at alpha and fx greater than 0 elsewhere. Okay. What is the minima here? Yes.
0.
Good. The location of the minima is always the same. It is at minus b by 2a. But the value is changing. You can understand case 4, right? It will be extremely similar. I'm not doing the graph there. It will just be the reverse. So in case 4, you will have d equals to 0, a less than 0, and maxima will be equal to 0. Okay. What will be the value of the quadratic? The value of the quadratic will be 0 at alpha and fx is less than 0 elsewhere. Okay. So overall, this one, this is combined always greater than equals to 0. Okay. So if you have to find a quadratic expression that is always greater than equals to 0, you can construct something like that. Similarly, case 4 you can construct where it will be always less than equals to 0. Okay, these types of analysis are very useful when you look into the application of derivatives. Okay, when we are looking into speed, velocity, acceleration, and so on. All right, there is a chapter on applications of derivatives. Although very few questions come from there because your JEE Advanced and ISI exams are mostly theoretical exams, but still you cannot discount it. You will have to do it in board exams anyway. Okay, and sometimes rarely there are questions from applications of derivatives. By rarely, I mean it's not like there will be 3-4 questions. One question is standard. Okay. So applications of derivatives we will do after we learn derivatives. Fine. Okay. Now there might be a case where the graph does not touch the x-axis. That is also possible. There could also be a case when the graph does not touch the x-axis but points downwards. So let me give you the next two cases. This is case 5 and I'll give you case 6 next. Then we'll discuss both of these together.
So could you please show case 4? I couldn't note down the
I will,
conditions.
I will, I will, I will. Case 4. Yeah, I can keep it here. No problem. All right. So you have case 5 and case 6 now. Identify what happens here.
D less than 0.
Where? Both?
Yeah.
And what about A?
For first one, it is greater than 0 and second one less than 0.
All right. So what can we see? What can we conclude about f, the function here?
Always greater than 0.
And in the other case?
Always less than 0.
Very good. So what will be the maxima and minima? We'll have minima here, right? What will be the
Yeah.
minima?
Minus D by.
Nope, just d by 4a. Because d is already negative, right?
Uh,
So minus d will be same as d, and maxima will be again d by 4a. No, this will be minus d by 4a because it's in the fourth quadrant. So d is already negative and a is also negative. So negative, negative, positive, and the negative sign. So the only location where you have the minima to be d by 4a and not minus d by 4a is when you have case 5. Okay, very important. So these are all the cases done. And the maxima and minimum value we obtained, right? So if there is a problem asking you about maxima and minimum values, use this. You know that the maximum or the minimum value, that is the extreme values, always occur at minus b by 2a. That is the location. And the value among the 6 cases that we did, in 5 of those the value is minus d by 4a. In one case it is d by 4a. Okay, even if you put minus d by 4a everywhere, you will get case 5 correct because there d is less than 0 anyway. So you will just get 2 negatives in the numerator, which will cancel out to give you a positive. Okay, this concludes the entire theory section of quadratic equations. Now for the rest of the class we will do a few problems and we will decide what to do in the next class. So I'll start off with something easy. Try this. Yes. How did you start the problem?
Is it 5?
I think option C is correct. No, sorry, not correct. How did you all do it?
Is it option D, 2?
Nope.
Sir, 5 by 2.
Yes. Of course, if four of you say one different option each, something will be correct, right? Someone said C, then D, then B. Even if I told B to be no, next one would have been correct. Are you actually doing the problem or guessing the answers? How did you attempt the problem? 2x plus 3 is in modulus, right? So you can just take let mod 2x plus 3 equal to y and then solve the problem. So this becomes y square minus 3y plus 2 is equal to 0, which means y minus 1 into y minus 2 is equal to 0. So this means y is equal to 1 comma 2. So this means mod of 2x plus 3 is equal to 1 comma 2, which means 2x plus 3 is equal to plus minus 1 comma plus minus 2, which means 2x is equal to minus 3 plus minus 1. What will that give you? Minus 3 plus minus 1, that will give you minus 1 minus 2 minus half minus 1 minus 2, because you will have to divide by 2 as well, right? So I'm just writing x directly, minus half and minus 5 by 2. So these are the four roots. Okay, now don't tell me that this is a quadratic and you cannot have four roots. No, that is not the question. This is basically two quadratics, all right, simultaneous quadratic. So there will be four roots because there are two equations, so that gives you a total of four roots. It is not like one equation has a total of four roots, all right? So that is not the case. You are, whenever you are solving this equation, y square minus 3y plus 2, this has two roots. Now this equation itself has two roots, so therefore you have 2 into 2, and it is equal to four roots. Now the product of roots here, that becomes, I hope I don't have to show you anything beyond this. This is y equals to 1 comma 2, and therefore the correct answer will be option B. No need to use the formula for product of roots. You can just calculate the roots and then find it. Okay, next problem. I hope nobody has any doubt in this particular problem. If there is, let me know. Otherwise, we will go on to the next one. Yeah, try this.
Sir, is it option A?
Is it -2?
Yes, that B. B is correct.
Okay.
Others take a minute and then I'll do it. Hmm. Let us do it. So, how would we do it? Again, sum and product of roots, all of that, right? So, sum and product of roots, how can we use it here? Alpha and beta are roots. Okay, so alpha plus beta is clearly visible here. That will be minus b by a. So, minus 6 by 2, which is minus 3. And alpha beta is equal to b by 2, I think, right? So, alpha beta is equal to b by 2. If alpha beta is equal to b by 2, now we have to evaluate alpha by beta plus beta by alpha, which is alpha square plus beta square by alpha beta, which is alpha plus beta whole square minus 2 alpha beta, all of that thing, right? So alpha plus beta whole square, you know this. You have done this multiple times. This is a very common thing. So this will be equal to alpha plus beta whole square minus 2 alpha beta divided by alpha beta, right? So alpha plus beta whole square, you know, this is 9 minus 2 into b by 2. So that will be 2 into, okay, this is just b, right? And alpha beta is b by 2. So this is basically, if I simplify it, I'll get 18 by b minus 2. 18 by b minus 2, right? Now b is less than 0, right? So if b is less than 0, then what will happen here? So that means all the values here are going to be, if b is less than 0, then 18 by b is always going to be negative. Agree? And if 18 by b is negative, then you are subtracting 18 by b from minus 2. Okay, so if you have minus 2 on the number line, 18 by b will just drag it leftwards. That means the maximum value of this expression is minus 2. So therefore this expression will always be less than minus 2. Okay, less than minus 2 as b less than 0. Clear, everyone? This was not that difficult of a sum, but then again it was a bit confusing. So these are state problems, state entrance exam problems. Next one, this is a bit tricky, so take your time with it, and this will be our last problem for today. Try this. this will be a bit tricky if you try it the traditional way. So make sure you mix it up. Yes, how far? If you start with sum and product of, if you start with sum of roots, you will get stuck.
Is it C?
It is C. So alpha and beta are the roots of, okay, so we know that alpha plus beta is minus B by A and alpha beta is C by A. Okay, use the second equation, ax square minus bx, okay, expand it. So you will get you will have to do a bit of algebra here. So ax square minus bx square plus bx plus cx square minus 2cx plus c, right? That is your b minus a and b plus a. I mean, sorry, minus b by a and c by a. You will get it from here. So that will be x square into a minus b plus c plus, no, I'll have to take, yeah, I'll take minus x common and I'll get 2c minus b, or I could take plus x common, right? And I'll get b minus 2c. And plus c is equal to 0. So that is the quadratic equation that we were given. Now look into the product of roots here. So product of roots. So product of root is c by a minus b plus c, right? So a minus b plus c, c by a minus b plus c, divide everything by a. Okay, so you'll get c by a and 1 minus b by a plus c by a. What would that mean? This would mean c by is alpha beta, right? So alpha beta by 1 minus alpha, alpha plus beta, so it will be alpha minus beta plus alpha beta. So this is basically alpha beta into 1. You'll take stuff common, right?
Beta common.
Yeah, in the second one you will take beta common and you will get wait, this is minus b by a, right? So this will be plus everywhere. So this will just be 1 plus alpha into 1 plus beta. So this just becomes alpha into 1 plus alpha into beta into 1 plus beta. If this is a subjective problem, then you can test the sum as well. Okay, sum of roots can be checked. Okay, but that will be tricky. Okay, you will have to do a bit of transformations, sorry, not transformations, but you have to do a bit of factorizations and changing of variables. This is much more easier. Okay, first transfer this equation into a standard quadratic form and then use product of the roots, use the product, divide by a, that is the important step. And yeah, that's it. You will get option C as the correct one. Okay, so these type of questions can only be done by that Jugaad method. Otherwise, you will get stuck. If you try to do it traditionally, the sum one will take a lot of time. Okay, because you have to factorize it one by one. You have to make sure the LCMs are correct and so on. There are a lot of moving parts, so the probability of mistake also increases. So do not go for the sum route. Okay, use the product. Product is much more easier to deal with. All right. So whenever you have quadratic equations of this type, when you are identifying the roots or doing something like that, you can always go for the product. Okay, start with the product first. There will be certain